Hello, friends. How are we doing today? I guess you guys are doing great, and I know you are enjoying your short break. And today we want to look at binary numbers. Now, before I start, I would like to talk about how we see things. For example, it is much easier for us to distinguish things that are in twos or in pairs. Okay, now if we had only two colors, let's say black and white, it's very easy for us to just distinguish them. Okay, and imagine a number system where there is no 5, 6, 7, 8, 9, there's no 3, there are only just two digits. Okay, so that kind of number system is what the computer works with. Okay, binary is a number system that is based on only two digits. And the two digits in binary are zeros and one, or 0 and 1. Now, mind you, binary is also called the language of the computer, because when two computers want to communicate with each other, they do that in binary language, in strings of zeros and ones. Now, binary is also called base 2, especially those in mathematics. You hear them saying base 2 or base, any other base if they want to talk about that one. But binary is also called base 2 because they follow the same principles. Binary is very useful in electronics, okay, where 1 stands for on and 0 stands for off. Okay, in most of your switches you will see a place where they write 1. Once you press that place, you see your device will come on, and once you press the switch to the one that has 0, your device will go off. That's why 1 is for on and 0 is for off. And that is how they come about this particular power button symbol. If you look at your power button of your remote control, it has this symbol. The 1 is to put it on, while the 0 is to put it off. That means with this button you can turn on this device and you can also turn it off. Like I said, binary is the language of the computer, okay? And all the data that you see in the computer that the computer wants to use to communicate with another computer is converted to binary. Now, the highest digit in binary is 1 and the lowest is 0. There is no 2 in binary, there is no 3 in binary, there is no 4 in binary. That's why they call it base 2, base below 2, okay? All right. Now, 1 in binary is 1, 2 in binary is not 10. Please take note. 2 in binary is 1, 0. We don't call it 10. We call it 1, 0. 3 in binary is 1, 1. And 4 is binary. Continue like that. So 10 in binary is 1, 0, 1, 0. Now, I didn't just bring up these numbers. You can easily convert decimal numbers to binary. Okay? So the conversion from 9, the decimal number 9 to binary is 1001. So we want to look at now how to convert other numbers in decimal form to binary form. All right, welcome. We've talked about the notes on binary or base 2. So let's look at how to convert numbers to binary. Okay, numbers in decimal form to binary. Okay, now remember we said binary is based on two digits, which are zeros and 1. So to convert decimal numbers to binary, okay, we keep dividing by 2. Okay, I'm going to convert 12 to binary, and then you will use that to answer the question that's given to you. All right, let me start. First things first, I'm going to put 12 here. 12, okay, and then I'll keep dividing by 2. I rule my line. Okay, can you see that? All right, I made a mistake. I wrote a line here. All right, now I'll keep dividing by 2. Now 12 divided by 2 will give me 6. Remainder 0. Okay, 6 remainder 0. Now I will divide by 2 again. 6 divided by 2 will give me 3. Remainder 0. Can you see that? 6 divided, now I'll go again. 3. 3 divided by 2 will give me 1. Remainder 1. Okay, And 1 divided by 2 will give me 0. Remainder 1, because we didn't use it. 1 divided by 2 give me 0, but this one we use dividing will still be there. Remainder 1. Okay, and then we take the numbers from bottom upwards. Can you see that? We take it from bottom upwards. Therefore, 12 is equal to 1, 1, 0, 0, and we'll put a subscript 2 to show that it is actually base 2. Okay, I'm going to take another example. Remember, we keep dividing by 2. If you want to convert numbers to binary, we keep dividing by 2. I want to convert base 10 to binary, sorry. We keep dividing by 2 till you get to 0. Now let me convert 25 to binary. Yes, that's a bigger number. Okay, and then I'll put my line here. Okay, now 25 divided by 2, remember it will give me 12, remainder 1. Okay, we have done a division and multiplication long ago. 12 remainder 1, and then we go again. 12 divided by 2 will give me 6, remainder 0. There is no remainder when you divide 12 by 2 to give you 6 remainder 0. Then we divide again by 2. 6 divided by 2 will give me 3, remainder 0. Okay, and then 3 divided by 2 again, just the way we did it the first time. 1, remainder 1. Okay, and then we go again. 1, we cannot stop here because this is 1. We have to have 0 here. So 1 divided by 2. Remember, 1 cannot divide 2, so we put a 0 here. But we didn't use this one at all. To now be remainder 1. Okay, and then we'll take our reading from the bottom upwards. From the bottom upwards. Now it becomes 1, 1, 0, 0, 1, and you put a subscript 2 here to make it base 2. Now you have some tasks there. Do yours and then write it in your note. Submit when next we meet. Okay.